Welcome to another exciting educational video brought to you by Chrysolite Tutors. We are looking at EDU 821, a postgraduate course known as Statistical Methods Part 1. Our topic for discussion today is statistical notations. This is the third unit of this course. We've done the first two units, so this is unit 3. Topic again is statistical notations. In this lesson, we'll be looking at the following objective. Number 1, recognize common statistical symbols. Number 2, apply these symbols to data operations. Number 3, we look at interpret combinations of statistical operations. And finally, for this unit, we'll define and calculate the arithmetic mean. So stay tuned and sit tight to the end of the video to get all these objectives. If you are new to the channel, kindly subscribe to the channel, comment, share to your friends who are also interested in the topics like this so that we can learn together. So we start with understanding variables and notation. So in statistics, we often work with large data sets. Okay, let me just put this small. Understanding variables and notations. So sort of we try to see how we can represent large data sets using some notations, like exam scores. You have exam scores, you have survey responses or measurements. These are ways we can get statistical data or values. So referring to these scores repeatedly can become bothersome. If, for instance, I have to say somebody scored, 5 people scored so and so mark. You understand? It becomes repeated if we just repeat the names of the variable and the numbers attached to the variable. We can use capital letters like X, Y, and Z to represent a full set of score. And we can use smaller sample. We can use a smaller sample from that set can be represented by the lowercase. So if I use bigger case, uppercase to represent a full set of scores, then I can now use small samples. I can now use lowercase to represent small samples. For example, large letter X or uppercase letter X could represent the scores of 50 students in English. So could represent scores of 50 students in English. Okay, so that's the first one. Then I can now use the smaller case to represent 10 randomly choosing scores in that class. 10 randomly choosing, just to choose scores, 10 randomly choosing scores in that class. Okay, so you see the difference. So this one is like the population, and this one is like the sample. Okay, so if you need more set of scores, just keep going with letters like that. You can just continue to use other letters to represent it. Okay, so here we have some common statistical symbols. There are some essential notations. So you begin to see letters shorthand to represent words like this. So if I have uppercase N, it's like the total number of a population. So this N, uppercase, represents the population, while smaller case n is the number in a sample, like a subset of the population. Remember, I said in the previous unit that the population is like a pizza and the sample is like a slice. Just always remember that it's like a slice of that bigger set. Okay, so you have F, the frequency. The frequency is how often a particular value occurs. So example, if 6 students score 57 in a test, then F is equals to 6. Why? Because 6 people scored 57. Okay, so F is equals to 6 for the score 57. So that's how this is represented. So move on to the next one. Okay, so next we have the mathematical operations in statistics. You're already familiar with these operations, but in this course you're going to be using them. So this is the symbols, this is the operation, the name of the operation, and this is an application for that operation. So if I have this symbol like this, a cross like this, is plus or addition. So the name of the operation is addition. So we call these operations. These are operations, but this is symbol. And the example is if I have x plus y, so if I have two variables like this, and the addition is in between them, then the results, there will going to be a resultant value if the operation is carried out. So you have this one here, this dash sign is in subtraction, and you have these two variables in between them with the subtraction sign. You know how it's being used, so that I'm letting you know that we are going to be applying it in this course. So the multiplication is either this like this or a dot. So you have x dot y, meaning that x multiplying by y. Division, this is the sign for the division, the symbol, and the name is division, and this is how it's done. For square, this is the square root. So the square root is actually dividing, the operation is, for instance, if you have the square root of 25, it's 5. You know all this from basic mathematics. And the small subscript, superscript, 2 is the square of the number. So if you square 6, for instance, you give it a 6. So these are the operations. You see them carried out in all statistical analysis that we'll be doing. Okay, so we'll move on to the next one. Sigma notation. Sigma summation notation. Summation notation. This is the symbol. So if you see this symbol like this, it's called the sigma. Sigma is the shorthand symbol for add up. So if you see sigma x, what it means is that you add up all the value of x. If you see sigma y, it means add up all the values of y. For example, if I'm told to say that if x is equals to 1, 3, 5, 5, 7, and 9. Okay, so therefore sigma x will now be 1 plus 3 plus 5 plus 7 plus 9. That is, add up all the values of x, and it will return 25. So another example. These are simple. We are just building blocks. If y is the following data set: 2, 4, 6, 8, and 10. Okay, so sigma y will now be, you add up 2 plus 4 plus 6 plus 8 plus 10, and to give us 30. So this is the way we represent summation notation in statistics. So there are other words we can look at. Let's look at frequency table. Okay, frequency table. Let me quickly take this off and talk about frequency table. So frequency, what is frequency? Frequency is the number of times a particular data set, particular data value occurs. Okay, so frequency table. So I'll define frequency as the number of times a particular data value occurs. So let's say we have y as 0, 1, 2, 0, 1, 3, 5, and 7 or 9. Okay, now all these data sets, all these value, their frequency is 1s. they occur once. So if I want to come here now, I'll say the frequency f of 9, frequency of 9 is equals to 1, only one time. Frequency of 7 is equals to 1 again. No, there's no 7 there. Frequency of 5 is equals to 1. Frequency of 3 is equals to 1, and so on. Now imagine that I take this one off and have these data sets on the board. Let's say I have y is equals to 1, 2, 2, 5, 6, 7, 8, 7, 3, 2, 3, 2. Let me not complicate this. Okay, let me just leave it like that. So frequency of 1 is 1. Frequency of 2 is 1, 2, 3, 4. So I have 4 times, 2 occurring 4 times, right? Frequency of 3 is how many times? 1, 2, occurring 3 times. Frequency is no 4 there. Frequency of 5 is occurring once. Frequency of 6 is also once. Frequency of 7 is 1, 2, that's twice. Frequency of 8 is 1. If I add up all this frequency, I must get these numbers. Okay, so 1 plus 4 is 5, plus 3 is 8, plus 1 is 9, plus 1 is 10, and this 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So something is wrong with this my computation. 1, 2, 3, 4, that's 4. 3 how many times? 1, 2. So this is where the problem is. 3 occurred twice. So I see that what I have here is 1 plus 4 is 5. 5 plus 2 is 7. 7 plus 1 is 7 plus 1 is 8. This is 9, 10, 11, 12. So this is 12 here. Summation of the frequency is 12. Sigma f is equals to 12. And if we count it distinctly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's the concept. That's the concept of frequency. Okay, so move on to the next one, arithmetic mean. Okay, so the arithmetical mean or the average is given as mean. This is a symbol for mean. You know, we're talking about notation. So when you see x and bar on top, it means mean. Mean is equals to sigma. I told you sigma is summation. Sigma x over n. What is n? N is the number of the data set. The number of data sets. So, example, if we are told that this is x, these are the discrete data. These are discrete values in this x, and we're told to find the mean. So we know that the formula of mean is equals to sigma x over n, where sigma x is the summation of what I have here. So I will sum this 0 plus 1 plus 3 plus 5 plus 7 plus 9 all over, and I'll count 1, 2, 3, 4, 5, 6. I'll count it 6 times. That's 6 of them. So I'm going to sum. What do I have in the numerator of the expression there? So the summation is 25, then all over 6. So by the time I compute, I will get my mean as 4.17. So this is sigma, x bar. X bar is the mean. X bar is giving us 4.17. So this is the mean. Okay, so that's how it's done. So we will progress to look at further computation where you have frequency distribution. In this course, we're going to see how it's going to be done, but we're taking it gradually according to the course material. This is Unit 3. You can do some practical examples. You solve some examples in your material. You can find square roots. You can take the squares of some numbers. You can also, as exercise, you can find the mean of some data sets, and you can also find the difference between two data sets. So in conclusion, we have looked at statistical notation, and it's what helps us to work with data more efficiently. Instead of calling data by their names, calling it by their names and the number is representing, you can use some shorthand symbols. See, as I'm saying, looking at them, symbols. These are operations. See operations, see a plus. These are symbols. Understand? To make it more efficient. Yeah. Symbols like X. Remember X. You have X. You have sigma. You have frequency. Sigma is addition. Frequency is number of data sets. You understand? And the X bar is mean. Understand? Make calculation easier and more standard. So understanding the notations prepares you for more complex topics like data distribution and inferential statistics. So in our next video, we'll explore data types of data management skills. So just stay tuned. Stay tuned. So if you found this video very helpful, don't forget to like this video, subscribe to Chrysolite Tutors, and hit the notification bell so that you don't miss our next lessons. I hope this video has been useful for you. I'd like to thank you for viewing.